Good morning, everybody. Today is Thursday, March 9th. This video is for those of you that could not be with us today, so I want to summarize what we did in class today so you're ready when you come back. Just a reminder to hand in the atomic zoom in annotations. That's the name of the assignment. Please make sure that you turn in all 4 pages so I can check your annotations. And then when you're finished, log into Chemical Reactions 1.5. and I'm going to have you do the warm-up activity. So your warm-up activity is showing you 2 different samples, sample 1 and sample 2. A couple things real quick before you answer the question. I want you to notice that there is an atom key down at the bottom, and some of you may have trouble distinguishing the colors. If you've got any sort of color blindness, that might be a challenge for you. So a couple things I want you to pay attention to. Number 1, the repeating groups of atoms are always connected. So notice in sample 1 and in sample 2, those atoms aren't separated by any space. They're totally connected. They also have different colors. We're using the John Dalton's billiard ball model, and so they are colored, but if you have trouble distinguishing between the colors, notice that they also have the atomic symbol in them. So there's the K for potassium, capital C lowercase l for chlorine, and then capital N lowercase a for sodium, so you can tell which atom is which. Okay, the question is, do you think samples 1 and sample 2 share all the same properties? Please go ahead and pause the video and answer it, and then we'll continue. So sample number 1 and sample number 2 have they have some similar properties, but I'm not sure if they share all the same. I'm just not sure. And so I'm going to have you guys just answer the question, and then we're going to move on, and hopefully we can come back to this and talk about it a little bit more. Okay, hopefully you answered that even though we can see it, the atoms are too small to see. It's good that we have the models there in the picture, because it shows us that the substances are in fact made of different types of atoms. And so if they're made of different types of atoms, they're going to maybe share some properties, but not all the same properties. They will not have all the same properties. And I'm going to show you, this is not Amplify, this is me. I want to show you why they might share some properties, but not all the properties. And it's because sodium and potassium are in the same group on the periodic table of elements. And so it makes sense that they share some of the same characteristics, because if you remember in your reading, all of the atoms that share the same properties share groups, but they're different, so they won't share all of the same properties. All right, let's go ahead and go to investigating substances in the sim. We talked about model. This is a repeat vocab word. A model is an object diagram or computer program that helps us understand something by making it simpler or easier to see. We're going to be using the billiard ball models, okay? So we're going to get used to seeing these circles that are colored, and they also have the atomic symbol inside of them, so we know which one is which. All of the colors mean something, and they are the same colors used. So hydrogen is always going to be white, oxygen is always going to be red, carbon will always be black, etc. Okay? We're also going to use the, let's see, hang on, I'm out of order. Okay, these atomic scale models, like what we saw, the billiard ball models. And then just this key concept number 2 is a repeat. We've had this one before. Things that are too small or too large to see can be studied with models. Okay, now in this unit we're going to use a model that is the computer simulation, and it's called the chemical reaction simulation. Okay, and I'm going to have you, I'm going to get out and I'm going to show this to you, and what I'd like you to do is I want you to kind of copy what I do. So if you can do a split screen and watch the video, and then I want you to kind of try and do it as well. So when we're in activity number 2, I want you to go to screen number 2. There's a link here to launch the simulation. And when you open it, it's just going to be this gray screen. I want you to come up here to the top left and click on those 3 lines. And the default is always this laboratory A mode. Today, we're going to do the chemical stockroom. So pretend that you are an actual chemist and you have a stock room full of different chemicals, and you're just looking at them, just kind of compare and contrast. So there's all of these different chemicals that you can look at. I'm just going to have you just mess around with them, and they're kind of cool to see. A couple features I want to show you, and then you can kind of mess around with it. But first of all, you can compare up to 3 at a time, and I would like you to do that. I also want to point out that there are highlighted kind of categories for each one. So first of all, you see the symbol AL, and then what the element or what the substance is, not the element, what the substance is. So this is aluminum, this is aluminum bromide, and this is aluminum carbide, okay? It will show you the repeating atom group. So the next category down there, repeating atom group. So aluminum is what we call a pure substance, meaning that it is only made of one atom, and that one atom is all by itself. It doesn't need anything else to be a repeating group of an atom. So you need multiple, many billions and billions in order to make the actual substance that you can see with the naked eye, okay? Where if you look over at aluminum bromide, the repeating atom group is 1 aluminum and 3 bromine atoms, and they all are connected to make 1 molecule of aluminum bromide. And then aluminum carbide is 3 carbon and 4 aluminum. I want you also to take a look back up here at the chemical symbol above the name. So for aluminum bromide, it's AlBr3, and that tells us, the Al tells us that there's 1 atom of aluminum and 3 atoms of bromide, and they are connected, they're touching, and that makes 1 molecule, okay? The next thing I want you to take a look at is this atomic arrangement. This is the extended structure. And there's a button next to it. These are all solids, and I know that because if you jump down to the last category, it shows properties. And underneath the properties, it says the color, the phase at room temperature, so that's how I know all of these are solids, odor, melting, and boiling point. Now, melting point and boiling point are the only ones that we have not observed ourselves in class. We just don't have the equipment to do that. But it's really telling because it shows us how these different substances have different properties. Melting and boiling point is something that's so specific, it's like a fingerprint. It's so specific to a substance. So we can easily compare substances that we don't know by looking at their melting and boiling point. So that's a really good one to look at. Remember, we don't want to rely just on color. You want to look at the other properties. Something that you can do is up here in the atomic arrangement, there's this gray button that says bend. So if I would bend aluminum, you can see that it would change the structure like that. That's showing that I can pound aluminum flat. That means it's malleable, okay? Aluminum bromide, if I go to bend it, see how it breaks? So the physical property is that aluminum bromide is brittle. It breaks apart. So that's why it appears to be in a powder format. And then the same with aluminum carbide. It breaks apart. I'm going to get rid of aluminum bromide, and I'm going to get rid of aluminum carbide. So you just click on that X in the top right. And I want to grab, I want a solid, liquid, and a gas. So I'm going to take a look at hydrogen is my gas, and my liquid is going to be hydrogen peroxide. Okay, so I'm going to come back here to my solid aluminum, and when I bend it, that's what it looks like because it's malleable. Now, I'm going to jump over to the hydrogen peroxide. I wonder if I can move it. Nope, I can't. So the hydrogen peroxide is a liquid. And notice that my gray button right here says to pour it. Remember, liquids flow, and so I'm going to pour it. And as I pour it, those molecules just move past each other because they flow. They're a liquid, right? Then if I go to a gas, notice the gas molecules want to move away from each other. They've got high freedom of movement, low molecular attraction. If I compress it, that means I push them down. I increase the pressure and they get closer together, but they're still pretty far apart, right? Because they like to move away from each other. All right. So you can pause the video and mess around with it a little bit and take a look at all the other elements or all of the other substances here that are made of different elements, different atoms, or you can go ahead and continue with the video and then mess around with it a little bit later. It's totally fine. Okay, I am going to jump to my next slide, and that is where I told you all of this, so I'm just moving past it. Okay. So I'm in activity 2, screen number 3, and I'm actually going to show this to you in your Amplify. So activity 2, screen 3. We have these 3 samples, and I want you to go back into your sim, and I want you to see if you can find these. And I want you to consider these statements, okay? So claim number 1 says, based on the atomic scale model of the sample, which of the claim do you think is best? Claim number 1 says all 3 samples have the same properties, therefore they are the same substance. So looking at those very carefully, do they have all the same properties, and are they in fact the same substance? Claim number 2 says 2 samples have the same properties, therefore they are the same substance. However, 1 sample has a different set of properties, and therefore this sample is a different substance. And then claim number 3 says all 3 samples have different properties, therefore they are different substances. So if we would go back in the sim, I'm going to pull this out so I can do like a side-by-side comparison. If I go back in the sim and I try and find these, I'm going to come down here and I'm going to go, oh, here's the first one. It's carbon dioxide, okay? And then the second one is carbon monoxide. And the third one, I can't find the third one. And if I look all the way through here, I'm going to notice I cannot find that third one. So I'm just going to look at the 2 here. I'm going to put these underneath it so you guys can see, kind of do a good comparison, compare and contrast. So sample number 1 is carbon dioxide. Sample number 2 is carbon monoxide. Sample number 3, okay, see this big space in between the 2 repeating groups of atoms? That means that there are 2 molecules of that substance. So that means sample number 2 and sample number 3 are actually the same thing. Sample number 2 and sample number 3 are the same. So therefore they have all of the same properties. Whereas sample number 1 is different, and so it's going to have different properties. Even though they're made of oxygen and carbon, all 3 of them, only sample 2 and 3 are the same. Sample number 1 is not, because it's made of a different arrangement, a different pattern, a different grouping of atoms. Okay, so we talked about that. Last thing I want to talk about is yesterday you guys read that article, and we were trying to answer, why do different substances have different properties? And in class, I was asking the kids, okay, so we know different substances have different properties. Why? And the answer is because they're made of different atoms or different atom groupings, different patterns. So if I show you here, I've got water and I've got olive oil. Water is the repeating group of atoms, or the repeating water molecule is H2O. And in olive oil, believe it or not, that strand, that big group of atoms underneath it, is one molecule of olive oil. It's made of all of those atoms, and it has to be arranged in that particular way, or else it's not olive oil. So different substances have different properties because they're made of different repeating groups of atoms or different repeating groups of molecules. All right, last thing is this homework. Now, you have this in Schoology today, so you can go in and get a digital copy. I'm going to just show you this. The goal is to create a model that represents a repeating group of atoms that could make up sample 2. So if we look at sample 1, it's made of hydrogen and carbon. It's odorless. It boils at negative 164 degrees Celsius, and it's colorless. The repeating group of atoms looks like this, okay? Now, what I'd like you to do is I want you to color the carbon black. And over here in the key, hydrogens are always going to be white and carbons are always going to be black. So go ahead and color that. And then I want you to look at sample number 2. It is also made of hydrogen and carbon. But the smell is similar to gasoline. It boils at 36 degrees Celsius, and it looks like a colorless liquid. And so just give me one repeating group of atoms. What do you think that might look like? Please be aware that we have no idea what this is. So don't look back on your sim and try and find it. This is you just coming up. I'm checking your idea. Basically, I'm trying to decide if you understand that different substances have different properties because they're made of different groupings of atoms. And so you just put in there what you want or what you think it could look like. All right? I don't have a space for you to turn this in yet because I don't want this to be on report cards quite yet. Actually, I think I will. I'll make a space for this. So as soon as you get finished with this, put it in. It will be called Chemical Model Tool. Okay? All right. Have a good day, you guys. Talk to you later.